Once upon a time, long before the age of supercomputers and pocket calculators, a brilliant mind was at work, laying the very foundations for the world we know today. This was the Islamic Golden Age, a period of extraordinary intellectual and cultural flourishing. In the heart of this vibrant era, from about 780 to 850 CE, lived a man named Muhammad ibn Musa Al-Khwarizmi. He was a Persian scholar, a mathematician, an astronomer, and a geographer. His work would echo through the centuries, shaping how we think about numbers, equations, and even the step-by-step instructions that power our digital lives. He was a true giant, standing on the shoulders of ancient Greek and Hindu thinkers, and providing a new, higher vantage point for all who would come after him. Al-Khwarizmi was not working in isolation. He was a prominent member of an institution that was, for its time, the greatest scientific research center on the planet, the House of Wisdom, or Beit al-Hikmah, in Baghdad. This wasn't just a library, it was a bustling academy, a translation hub, and a laboratory for the brightest minds of the era. Under the patronage of the visionary Caliph al-Ma'mun, scholars gathered here from across the known world. Their mission was to collect all the world's knowledge, translate it into Arabic, and then build upon it. They brought in texts from Greece, India, and Persia, preserving priceless wisdom that might otherwise have been lost to history. Inside these hallowed halls, Al-Khwarizmi had access to an unprecedented collection of scientific and philosophical treatises. Imagine the intellectual energy of that place, a melting pot of ideas where Greek geometry met Hindu arithmetic. It was in this dynamic environment that Al-Khwarizmi flourished. He wasn't just a passive translator, he was an active synthesizer and an innovator. He took the abstract and often cumbersome mathematical concepts of the past and refined them, creating practical tools that could be used by engineers, merchants, and astronomers alike. The House of Wisdom provided the fertile ground where Al-Khwarizmi's genius could take root and grow, ultimately changing the world. His contributions were not confined to a single field. Al-Khwarizmi was a polymath, a person whose expertise spanned multiple disciplines, a common trait among the great thinkers of his time. He delved into the movements of the stars, the geography of the earth, and the abstract world of numbers. His work was characterized by a desire for clarity, systemization, and practical application. He wasn't just solving puzzles for the sake of it, he was creating powerful methodologies that could solve real-world problems, from calculating inheritances according to Islamic law to determining the exact direction of Mecca for prayer. His legacy began here, in a city dedicated to the pursuit of knowledge. Perhaps Al-Khwarizmi's most famous achievement was his revolutionary book on mathematics, titled Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala. That's a mouthful, but it translates to the compendious book on calculation by completion and balancing. This wasn't just a collection of problems, it was a systematic guide to solving linear and quadratic equations. For the first time, someone had written a textbook that laid out a clear, step-by-step method for finding unknown quantities. He introduced the idea of using a symbol, which he called shay, or thing, to represent an unknown value, what we today call a variable, like x. This was a monumental leap forward in abstract thought. The very word algebra comes directly from the title of his book, specifically from the term al-Jabr. This word referred to the process of completion or restoring, which meant moving a negative term from one side of an equation to the other to make it positive. The other key operation, al-Muqabala, meant balancing, which is the process of canceling out identical terms on opposite sides of the equation. These two simple, elegant procedures formed the core of his algebraic system. They provided a universal language for manipulating equations, turning complex word problems into solvable mathematical statements. It was a revelation that brought order to the chaos of calculation. When European scholars rediscovered this work centuries later, through Latin translations made in the 12th century, it sparked a mathematical renaissance. Al-Khwarizmi's book was so practical and so clearly written that it became the principal mathematics textbook in European universities for hundreds of years. It didn't just present the how, it also used geometric proofs to demonstrate why the methods worked. He would draw squares and rectangles to give a visual representation of his equations, making abstract concepts tangible and understandable. This approach bridged the gap between the geometric traditions of the Greeks and the numerical traditions of the Hindus. The book was more than just a theoretical treatise, it was designed for practical use. Al-Khwarizmi dedicated significant portions of his work to solving everyday problems. He showed how algebra could be applied to surveying land, dividing inheritances, and managing trade transactions. For example, he outlined complex scenarios of Islamic inheritance law and demonstrated how his algebraic methods could provide precise and fair solutions. This focus on utility is what made his work so powerful and enduring. He wasn't just doing math, he was giving humanity a new tool to understand and organize its world in a more rational and predictable way. Al-Khwarizmi's influence extends beyond algebra into the very fabric of how we perform calculations today. He wrote another groundbreaking book, which in its Latin translation was called Algoritmi de Numero Indorum, meaning Al-Khwarizmi, concerning the Hindu art of reckoning. This book was his vehicle for introducing a revolutionary technology to the Western world, the Hindu-Arabic numeral system. That's right, the numbers we use every single day: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Before this, Europeans were stuck using cumbersome Roman numerals, which made even simple arithmetic a daunting task. Imagine trying to multiply 63 by x11, it's a nightmare. This new system was a game-changer for two crucial reasons. First, it was a positional system, meaning the value of a digit depends on its place within a number. The 5 in 500 is different from the 5 in 50. This concept, while intuitive to us now, was a brilliant innovation. Second, and perhaps most importantly, it included the concept of zero. The zero was not just a placeholder, it was a number in its own right, a revolutionary idea that allowed for a complete and efficient system of arithmetic. Al-Khwarizmi's book was the instruction manual that taught the West how to add, subtract, multiply, and divide using this far superior method. And here we find the origin of another essential word, algorithm. When his book on arithmetic was translated into Latin, his own name, Al-Khwarizmi, was Latinized as Algorithmi. Over time, the name became synonymous with the specific step-by-step procedures for calculation that his book described. Today, an algorithm is any finite sequence of well-defined, computer-implementable instructions, the very DNA of every computer program, search engine, and smartphone app. So every time you follow a recipe, use GPS, or search the internet, you are, in a sense, paying homage to Al-Khwarizmi. You are following an algorithm. His work democratized mathematics. By providing a clear and efficient system for calculation, he made complex arithmetic accessible to a much broader audience. Merchants could more easily track their finances, architects could make more precise calculations for their buildings, and astronomers could map the heavens with greater accuracy. The systematic rule-based approach he championed in his writings became the blueprint for logical problem-solving. It was a shift from bespoke, one-off solutions to a universal methodology that could be learned, taught, and applied by anyone. This was the true power of the algorithm. Al-Khwarizmi's quest for knowledge wasn't limited to the abstract realm of numbers. He also turned his gaze outward, to the Earth and the cosmos. He was a key contributor to geography, producing a major work called Kitab Surat al-Ard, or the Image of the Earth. This book was essentially a world atlas in text form. It provided the latitudes and longitudes for over 2,400 locations, including cities, mountains, rivers, and islands spanning from Europe to Asia. He was building on the work of the ancient Greek geographer Ptolemy, but he wasn't just copying it. He meticulously corrected and improved upon Ptolemy's data, offering more accurate coordinates for many places. His geographical work had immense practical value. For the vast and expanding Islamic civilization, knowing the precise layout of the world was essential for trade, administration, and religious practice. Al-Khwarizmi's tables helped create more accurate maps, including a world map for the Caliph al-Ma'mun. Furthermore, he participated in a remarkable scientific project, an attempt to measure the circumference of the Earth. By measuring the length of 1 degree of a meridian arc across a flat plain in Iraq, he and his fellow scholars arrived at a figure that was remarkably close to the modern value. They were measuring our planet with a level of precision unheard of for their time. In the field of astronomy, Al-Khwarizmi also left an indelible mark. He compiled a set of astronomical tables known as a zij. These tables were vital tools for astronomers, enabling them to calculate the positions of the sun, the moon, and the planets. His zij was based on a synthesis of Greek and Hindu astronomical traditions, and it included tables for trigonometric functions like sine and cosine, which are fundamental to calculating angles and distances in space. Like his other works, his astronomical tables were translated into Latin, and became highly influential in Europe, providing the foundation for later astronomers like Copernicus. The legacy of Al-Khwarizmi is, simply put, the world of modern science and technology. He gave us the language of algebra, the blueprint for algorithms, and the tools to perform complex calculations with ease. His systematic approach to problem-solving and his drive to synthesize and improve upon existing knowledge set a new standard for scientific inquiry. He was a bridge between ancient wisdom and the European Renaissance, a conduit through which critical knowledge flowed. Every time a scientist writes an equation, a programmer writes a line of code, or an explorer charts a new course, they are walking in the footsteps of the great scholar from Baghdad, the father of algebra.